Good afternoon, gentlemen. So our next session, we will try to focus on the security screening technologies, understanding that technology becomes very important, especially, it was already mentioned in the first edition of Annex 17, but especially after September 11th, when the new requirements for whole baggage screening was introduced. This introduction of whole baggage screening require a lot of investment on different airports, different technologies. We know that in the United States, traditional conventional X-ray for whole baggage was not enough. So they asked immediately to install CTX, which is a rotating technology to detect in 3D images of the luggage. On another side, majority of airports still are using walk-through metal detector with all the negative elements of such technology. I think one of the weakest point, because everybody knows that September 11th happened thanks to the lack of proper passenger screening, not whole baggage screening. You are representing different producers and different new technologies from the industry. I would like to ask Mr. Liu about passenger screening technology that your company is delivering already now on the market. We see that traditional walk-through metal detector are now changed into the new technology. We have for some time backscatters as a X-ray technology that because of the health reasons did not follow the market requirements. And after that millimeter wave, we have pleasure yesterday that you show us also terahertz and artificial intelligence technology of the passenger screening. So is this technology of tomorrow that you are offering, or this is just a developing process until the new products will be available for screening tunnels as required by IATA screening point of the future?
As we yesterday I have shown in my presentation regarding the terahertz technology for the screening of the land side of our airport, and also screening of the when crowd people coming for screening. For this technology, for terahertz, we believe it's meets part of the need of the aviation security. For example, when you have to make access control in the major entrance of the buildings, when you have a large amount of passengers coming through, and also you don't want to interfere in the passengers and giving them or stopping them or some way to interfere in their activities. And this terahertz technology actually it's a part of the technology which is non-interfering the passengers, similar as the behavior analysis of the cameras. So in this case, basically you keep the passengers to pass through the major entrance of the airport or the in big event with not reducing the speed, and also at the same time you can basically the terahertz machine is based on non-harmful technology, which is providing how to say more quiet and stealth way of detection. So the detection accuracy of this technology, it can, to be honest, it cannot compare to the millimeter wave, because when you do millimeter wave screening, basically the scanner will screen more details, getting more details from detailed screening. But for terahertz, it is screening from a crowd of people, the major threats. For example, you will have an attack on the big event, someone carrying a knife or gun. The machine will be able to make immediate alarm upon someone carrying something. So police will be able to find the person or stop the crowd in a very instant time. So this is what it's helping. But I'm not sure. I'm not saying that it's for it can cover every sector of the security, because we have a millimeter wave which is for more detailed screening, and this is a part of solutions that we are working on to protect the public.
Yeah. as I can understand, terahertz technology is mainly for public part of the airport, for accessing people to the screening point, but not really to screen departing passenger according to the requirements of Annex 17. Am I right?
Yes. In the moment, based on the accuracy, detectability of this technology, the best application would be putting this system into the entrance, also for the public area, for monitoring the crowd of people. Yeah.
During your presentation yesterday, you show us also how to solve the problem of body scanners that usually have problem how to scan bottom part of the passenger body, which is usually shoes and feet. So
Yes.
you are also adapting something else to the screening techniques?
Yes, for NukeTech, I see we have friends from Rolls-Royce. They are also very good technology. And on NukeTech, we are working on some different ways in approaching for the challenges of the ankle part of the body, because sometimes it is really a blind area for the screening. So the approach for NukeTech is that to provide a separate shoe metal detector on the lower level to protect this part. Yeah.
So, Mr. Björn, Rode-Schwarz was very old company with technology. Everybody knows who was in professional electronics that you produce all kind of instruments and devices for electronics. So we see you as a new company in aviation security, but I see also that you are expanding market, understanding that you are winner of several public tenders for passenger screening. So can you explain us how it comes that Rode-Schwarz come to the passenger screening, and what is the new on the market that you can offer, what is better for customers that understand that you have technology which absolutely fit into their expectations?
Absolutely. Rode-Schwarz started in 1933, so we are an old company based in Munich, Germany. We were always a technology company dealing with high frequency, so basically measurement instruments, oscilloscopes, these kind of things. In 2007 was the first time that Rode-Schwarz started developing a body scanner based on millimeter waves. We scan between 70 and 80 gigahertz, so we're quite high. We're higher than the others. This is not easy, but it's something that Rode-Schwarz is an expert in. We've been doing it for a long time. I always say we used to, or we still do, measure instruments. Now we started measuring humans. So it's a nice transition to that. But 2007 was the first time we started. In 2014 was the first working body scanner that we had. We're on version 3 now, the one that you see out in the hall. This body scanner is version 3. It's called the QPS 201. It's faster, it's smaller, it's lighter, very high resolution. And also what we concentrated on, where maybe the approach is a little bit different, it's not 100% only technical. We try to balance security, and we call it passenger satisfaction. Security, of course, is very important. It's usually priority number 1. My experience talking to airports, and my region is mainly Central and Eastern Europe, my experience is security is important, but passenger satisfaction is just as equally important. So if you've seen the scanner out in the hall, the first thing you will notice, we don't do this. We do this. So, and this is not easy to do technically as well, that you can actually keep your arms down a little bit away from your body, your legs a little bit spread. And the first thing you'll notice after you're standing there, and you can try it out for the rest of the day, you will hear a beep sound. That's when the scan is finished. It takes us 64 milliseconds to scan. So it's 64 milliseconds, it's 32 milliseconds from the front, 32 milliseconds from the back. The rest of the time is processing the image. These images can be up to 10 gigabytes. They're very high resolution, very big pictures, large pictures, and the computer needs to process this picture. We do this processing, the whole process takes only 2.5 seconds. So not 3 seconds, I think it was mentioned before, we do 2.5 seconds. And it's practically really 2.5 seconds. To give you an example, why speed is important, because this is number 1 important for airports, throughput, get passengers through the security area. And I liked your presentation yesterday where you talked about the stress level. to reduce the stress level and to bring them basically into the nice area, the shopping area, the restaurants. So we have a good example in Doha, Qatar. We've been there for 1.5 years now. We have a QPS body scanner there with 4 search stations. So when you get scanned, afterwards you're sent to a search station. We have 4 of them there. So the scanning can be done very fast in the sense of that you scan a passenger. If they don't have anything on their body, they're basically released, they can go. If they do have something on their body in their pockets, then we send them to a search station. The statistics there at peak levels is 400 passengers per hour. And this, if you know body scanners, is very fast and a lot. It's still not quite up there with metal detectors, but we're getting close. And I think the 64 milliseconds that we're doing right now, you will see in the next years, it will keep dropping down. We'll get faster and faster.
As you mentioned, the perception of the screening and stress curve is very important, how to keep it down as much as possible. So usually we see screening point like area that we don't like. Your scanner is wider than other scanner. So this was done by purpose or
Absolutely.
because of technology?
Yes, no, absolutely. Number one, you'll notice outside also the open structure of it. It's not a booth. You don't have to turn yourself. There is no moving parts around you. It's a static, no moving parts in our scanner. It is very open. We also do this for like a fire exit, for wheelchairs. If there's a panic situation in an airport, our scanner is not in the way. You can just run through, basically. And also what we've noticed, we have this experience in German airports where the German police is interacting also in visual ways. Mm-hmm. And our scanners are so open that basically from the back, the police can see all the way to the end of the line. And they can see how people are reacting, how they're behaving, because you have a nice view. If you have a booth or something, it's in the way you can't see it. From the other side, from the passenger point of view, we did this also on purpose. You will see this, maybe if you've flown through Frankfurt, Munich, Belgrade also has it, Budapest. When you're waiting in line, and this might be the first time you're going through a Rot und Schwarz scanner, when you're waiting in line, you will have the opportunity to see at least the 4 people in front of you getting scanned, because it's open. So when it's your turn, stress level, when it's your turn, you're not worried. You've seen it already minimum 4 times, how it's done. Go in, beep, done, and you go. So yes, it was done on purpose. 1.75 meters wide.
I mentioned yesterday during presentation how it is important to understand and to prepare passenger for divesting and for reconciliation. This is consuming much more time than screening. Understanding that you can detect all the objects on the passenger body. Is there any difference in the preparation for screening, or person can just walk through with objects in the pocket like telephone? Do I need to take telephone keys, belts outside, which will also require additional time for preparation? Or by the technology of detection, you can just walk through and take all the belongings on your body? Yeah.
The way we explain this, it's we call it concept of operations, and every airport is different. Every country is different. If you've flown through London, for example, or US airports, they're required to take off the shoes. Doesn't matter who you are, what kind of shoes you have, shoes off into the X-ray. Some other airports will look at your shoes. If they're relatively small, low, they'll let you through. If they're big, you have to put them through the scanner. This is not our decision as a manufacturer. It's a concept of operations. And the whole part about taking off your jacket, your belt, your keys, your phones, the way I explain this to operators that we train at airports, the goal is to get a big green symbol on the screen that says pass. That's the fastest way. So if you have passengers going through, you should not be detecting anything. That's actually the goal. The goal is not to see and detect everything. We talked to London, Heathrow, for example. They do a very good job at this. If you've been through there, sometimes it's actually quite, the stress level, I think, goes up because they're very direct with you. They tell you in a very loud voice, everything out of the pockets, jackets off, belts off. It's quite strict. It's because of this, because they want the flow to go faster. And yeah, take everything out of your pockets, put it into the X-ray, then it gets scanned there, and you should go through the scanner with basically nothing in your pockets. Because the minute, even if you forget your phone, your keys, even money sometimes, or your belt, you will always trigger an alarm. And we always say this is not a false alarm. this is a proper alarm. There is something there. So you need to be searched. And you've been to airports as well yourself. Some people know how to do this really well, and some people just do not. And they are the ones who are holding up the line, usually.
We will come back to the passenger screening point and passenger screening technology, but now I will go a little bit to the whole baggage screening and understanding that this technology is also developing. We saw yesterday about the requirements from ICAC and the FAA or TSA concerning new technology. Mr. Lesisa, your company is representing SureScan technology, which is non-rotating CTX or explosive detection system technology.
Yes, correct.
What do you see as a major difference between rotating or artificial rotating technology?
Yes, of course. Rotational stand-tree gantry machines, they have their limits. Because if you want to detect the alarms, the belt, to increase the high throughput for the baggage, we also must increase the cycling. And in the stationary gantry machines, this is on the other way better, because we have no limits, because all complexity is just in algorithms of the software. And our machine has done this complexity with the multi-energy system. It has is the only machine in the world now with this solution and giving the multi-energy system the difference about other machines that they're working with different kind of detectors that can, in practice, count photons and also see how energy is distributing about. So this allows us to check different kind of materials in practice and to get lower false alarms and with better detection. So in this way, let's say our machine is prepared for the future, that we can now check where machines will be installed in the airports and check what kind of materials we are detecting and what kind of alarms we get to increase the algorithm in the software with the same hardware. And in this way, our machine has already certificate to pass 1,800 baggage per hour. And also we are waiting certificate to pass to 2,100 baggage per hour. On the other hand, the rotational machines, they came to their limit because they cannot increase much the speed. And also they have dual energy system instead of our multi-energy system. And also the difference is that their system, they must photons once convert first to visible light and then to electricity. Instead, our system converts directly photons to electricity. So we have less noise, less radiation because of this, and consume less power.
Talking about complexity of the system, we have one stream or one source for X-ray in rotating,
Yeah.
and you have multi-source level. How many sources do we have, and what in case that one or two sources will be out of use?
So we have 28 tubes, but they are working pulsely, one by one, and in sequence. So if our machine, one tube breaks, we are also waiting certificate now that machine could continue working without one tube. But the best in our machines is that is plug-and-play tubes, which can be replaced in just 25 minutes suddenly. So it's also no problem.
You told me before it's usually by documentation 1,800 bags per hour,
Yes.
but we work on the airport. We know that this is theoretical speed. You are even increasing to 2,200
Yes.
bags per hour. Can you see what is the difference between theoretical speed and the consumer speed that we can count on?
But in practice, our machine can go 0.35 meters per second or to 0.5 now. So 1,500 to 1,800 bags per hour. But this is in practice. The practice also the standards will go further because the standards show us that we want the high throughput bags, the better detection and less false alarms. So in practice, our machines is capable with no limits to do that. The limits are only in certifications. But let's say the passengers wants to go very quickly on the plane, and we cannot have a machine now stopped and checked what is going on. So in this way, we involve.
You probably know something about statistics of implementation of your machine on whole baggage screening on different airports. Do you know maybe what is the hand search percentage of all luggage that after all the system comes? Because this is usually what stops the flow of the passenger, and sometimes the luggage is delayed to the airplane, thanks to the algorithm employed in the different technologies.
The alarm rate of our machine should be less than 20%. So it's about 15% now. And also the ECAC standard, it should reduce from 50 to 25%. Before it was like 35 to 45%.
For standard 3.
Yeah. So now it's the rejection rate is about 15%.
Okay. Mr. Liu, first of all, my compliments for your company. I'm always fascinated about China, where I was as a ICAO auditor in Kunming, Xi'an, in Beijing, approximately 10 years ago, fascinating with China and development. You are a Chinese company producing worldwide equipment for baggage screening. Everybody knows that these machines have to detect specific list with specific mass of dangerous devices. I know that this list is very restricted. How do you fulfill the requirements of, for instance, ECAC or TSA without having access to these requirements?
So actually, this is a little bit sensitive question. For as a Chinese company, usually there's regulations in EU for this kind of list of contraband, including explosives and other contraband, is a secret. It cannot be even for manufacturers. They are not able to directly get such kind of information. But normally, it is if the manufacturer want to have this information from an EU country, they will be able to require this from the national aviation security. But as a Chinese company, because we are not our technology, and we are not registered in Europe, so most of the time it's more difficult for us than other competitors to get this testing information. So we have done a lot of hard works on this, but the result is good. Now we have many different type of equipment being certified. And just 1 hour ago, our Kailin TI machine for EDS standard CB-C3 was certified by ECAC.
Congratulations.
So, yeah, this just happened.
I can give information that ECAC standard has about 5,000 tests about this. So this is the only data we can get.
Yeah.
We can
Concerning explosive detection system, we know traditionally that our X-ray people were also doing some job for custom to protect smuggling, some high-value goods, animal species, and so on. Now with DDS, this is done by machine. So only with implementation of artificial intelligence, you can recognize objects outside of the dangerous devices which are measured by atomic mass of explosive devices. So what do you see, where do you see the custom procedure in departure, how to protect, because they cannot do it anymore on the screening point?
NUCTEC have been working on the CT technology for quite a few years. So the customs is also one of our important customer. We have already supplied over 300 CT machines to Chinese customs, majorly to anti-smuggling and also anti-drug smuggling. So most importantly, we have some achievement in the last few years. The Chinese customs, they are using NUCTEC machines in the express centers of, you know that Alibaba is a very big group in China. Every year we have a large amount of express mail boxes of express around China. There is a calculation, the average in the city of Beijing and Shanghai, for one person, the average package they receive is each week they have at least each week they have one package. So a lot of things transported through air, through railway, through other transportation matters. But the government is really having a headache about smuggling things, especially for the drug. So NUCTEC provided the technologies on the border of China. In the last few years, we have successfully used our CT technology to automatically find the drugs which was concealed in many different ways. Some are in baggages, some are in shoes, and some disguised as fast food, which is sending my packages. And one interesting case is a drug dealer. They have like 10 packs of sugar. They changed some pack of the sugar inside the boxes and with heroin. And then these boxes were sending through mail to China. And when it passed through the NUCTEC CT machine, they disguised the packages was alarmed. The other part of the package was not alarmed. It only circled that part, so we found the drug dealer. Actually, this we would say that from technology speaking, even for the system of our competitor, SureScan, these machines are very, the hardwares, they are very powerful. If you're giving them enough information or learning, what we call library or material information, make the machine recognize the information and remember this information. The characters, like for example, character for drugs, or characters of lithium batteries, or some other special materials. This machine can be converted in a different algorithm into a machine can detect many different things.
Mr. Björn, coming back to the passenger screening, we know that conventional screening devices did not cover all on the best possible efficiency, all part of the passenger's body, especially when we are talking about shoes and such things. Your screening your screening technology, do they employ some special technology also to screen bottom part of the passenger body? Or?
Easy answer to that is no. It's interesting because there's two sides to this. One is the technology where it's just physically impossible to scan below the ankles. The way the machine is set up. We do see it when you actually see the raw image, you will see shoes. But since we cannot guarantee 100%, we don't. So we might scan it physically, but the software actually ignores everything below the ankles. Actually, just for that information as well, the image comes in and the software is analyzing it. The software ignores your hands, it ignores your face, and it ignores your shoes and ankles. And this is, again, part of the concept of operations when we talk to airports, that you can actually go through our scanner here, and you can have a hand grenade or a gun in your hand, and the scanner will not find it. It will not give an alarm, because we are ignoring the hands. The reason for this is also because this is where you need the operator. You actually need to physically look at people's hands. That's why actually when you stand in there, the operator needs to look at you. Number one, your fingers need to be apart, so you cannot stand like this. Need to be apart so they can see what's in your hands. Also, there's the little trick about putting your hands away from your body. You have to have it this way and not this way, because if you have it this way, you can hide something in here and you can hold it. You hold your hands this way, you cannot hide anything in here. So the advantage of this also for the passengers, passenger friendliness, is you can actually keep your watch on if you're going through a Rode and Schwarz scanner. It will not see your watch. Again, the operator will be looking at your wrist. Obviously, if your watch is larger than usual, they will probably say something. And the shoes we ignore. The other solution we have for the shoes, and you might notice this if you're going through our scanner, there might be an alarm for your shoes. And this is just a random alarm. That's the only way we could solve it, where, I don't know, every 8 passengers that goes through will have an alarm on their shoes. They have to take off the shoes and put it into the X-ray. What I can tell you a little bit is starting next year, next couple of years, we will have a solution for the shoes. We can't talk about it yet, but it's definitely the major concern for all airports. Anytime I talk to airports, everything is okay, but when we come to the shoes, and it's the same answer I gave you, no, we do not scan the shoes. Not yet. And it's also, as you mentioned, the metal detector. Of course, it's possible. You would have to raise the scanner a little bit to have a metal detector below. The reason why we don't do it, and obviously it would be possible, technology is out there. The main reason is we don't do it is for passenger satisfaction again, because if the way we see it, if you go through the scanner and you do get an alarm on your shoes for metal, you have to start the whole process again, so you have to go back. So the flow would not be the way we like it, so we basically say no. Most airports do have shoe scanners. They might even employ a metal detector. Same time they have a body scanner. It's a little bit controversial if even metal detectors can really detect metal in shoes. So, but yeah, at the moment we're leaving it the way it is. We say we don't scan below the ankles. In the future we will have a solution for this, and not just for metal, for all things.
You mentioned that you are ignoring part of the body because of the reasons you mentioned. What about privacy? So this was the biggest case concerning backscatters, but also millimeter wave. Yes. And you mentioned before that you have to see the passenger's hands and so on. So what is the privacy protection and the requirements to see the passenger face or hands or whatever?
Absolutely. It's interesting in this industry, those who are building body scanners, when the privacy became an issue, and it was, as far as I know, in 2010, I think it became, and the EU was the first one who said, okay, before we had x-rays, we were x-raying, not us, but others were x-raying the human body. The EU was the first one who said, okay, that's not healthy. And the EU was the first one who said, okay, there's privacy concerns because you're actually seeing a naked body. They were called the naked scanners in those days. This changed very fast. It was an easy solution for the passenger. As you can see with our scanner as well, it's called an avatar. And it just basically shows parts of the body where there is something, but you don't actually see the real photo of the body. This looks simple to the passenger. It's an extreme headache for the manufacturer, because now we have to program software that analyzes the picture. So it's not the human who's looking at the picture, but software. And believe me, the software is harder than the hardware. Rohde & Schwarz, we do our software in-house. It's an advantage. We can change things very fast. We can adapt very fast. But it is a huge department within Rohde & Schwarz that are programming the software, so we can actually keep privacy. The picture is taken, like I mentioned, can be up to 10 gigabytes. It's a large picture. The minute you scan the next passenger, this picture is deleted forever. The reason I mentioned also the size of the picture, if you imagine 10 gigabytes, we wouldn't even have the space to store all these pictures. So the pictures are definitely deleted afterwards. Only the software sees it, only the software analyzes it, and it is not possible to see the picture. We have other applications that are not to do with airports or transportation, like in prisons. In prisons, yes, their privacy concerns are a little bit different. People have less rights in prisons, and there you can actually show the real picture. It takes much longer for a human to look through a body and really find things. The software is much faster. So,
did you already employ the GDPR requirements? We heard from our previous panelists about Serbian standard for GDPR. We know in Europe is a very important case. So probably you're not going to ask every passenger, can I screen you? And how to store and how to process a database of this particular passenger?
Yes, from a manufacturer point of view, again, this is more of a responsibility of the airport. We help the airport. A good example is Edinburgh Airport in Scotland. I was recently there. They have big posters that are explaining what the scanner is, partly technically. They will have things like on there that if you're pregnant, it's no problem. Pacemaker is no problem. If you don't want to be scanned, just please walk through the scanner. You most likely will be hand searched if you don't get scanned, but you don't have to be scanned. Also, there is no health risks. Just to give you an example, our scanning, the radiation or the energy that is coming out of this scanner, it comes out once 32 milliseconds, then 32 milliseconds. It's coming out at 1.26 milliwatts, which is about 1,500 times less than the mobile phones you have in your pockets. So believe me, your phones will do more damage than any of these scanners. And the phones are always on. Yeah. This is only on 2 times 32 milliseconds. So definitely no health risks with millimeter waves.
Coming back to CTX, Mr. Lesisa, we know that EDS machines are programmed by algorithm to detect specific mass density of the materials and so on. How quick you can change algorithm? Is it something that you fix for a certain period of time, or you can change it from passenger to passenger? Because we heard about some experience, especially from El Al and the Israeli security system, that they are adapting every time machine according to the threat level of the passenger.
No, this machine is just auto-calibrating machine, so it's no need to adapt nothing. But if you are talking about detection of alarms, obviously you have a long period of time because you have to test every substances. So this is about certification, and it's not about checking every baggage of every passenger.
Yeah, but according to EU standard, every country, according to evaluation of threat, particularly can add some new explosives on the list of prohibited explosives. So here in Balkan region, we have a Vitezit, which is plastic explosive. Obviously, it was not marked. And I expect that every airport would like to add this explosive, which is not on the ICAC list,
and this
comparing with C4 or Samtex or some other. So can customer adapt the algorithm or the list of explosives apart from what is already checked on ICAC list?
Yes, of course. Customer can make their requirements and say, okay, we would like to add to this list of ECAC or TCA such explosive list, but this needs a little time because must check the algorithms and check the machine that it's working and that is detection of this list. But it's possible, yes.
Thank you. Mr. Leo, let's talk a little bit about public area security, because we obviously see that this is the focus of the point of attack, the newest threat, that it's not protected almost at all, except the reverse, that we can see who moved in, but we don't have prevention of people accessing the airport or public areas or in front of checking counters because before security. What is the strategy or technology that you think in the future that will prevent or protect also the public area apart from what you already mentioned as a terahertz technology?
Okay, for this, actually this is a very challenging topic for every technology supplier in the market, because the public area, usually you will have to respect the speed of this place. People passing these places without stopping. So it has to be quick. You shall not affect the throughput of this public area. And also importantly that, for example, for airport, some airports in the moment already moving the pre-checking outside the terminal. For example, what we have experienced in China is that if you go to the Beijing International Airport, what you are going, before you go to the check-in counter to print your boarding pass and put in your checked baggage, when you just walk into the terminal building, in front of the information board, everybody will stay for a moment to find their check-in counter, and there will be a group of security service people standing there. They will use actually use the trace detector, which is also common in the moment in Europe, the ETD machine. They will actually find if 10 persons standing in front of an information board, they will just make a random check by swap on each baggage. And then they will tell the passenger that just wait for a few seconds. Usually it takes around 7 to 8 seconds for the decision time of the ETD machine. And this kind of random checks really helps the airport to make effective control of the gates, but it also interfering the freedom of the passengers. It gives more stress, and also sometimes when you are looking at the the information board, you find your flight is taking off in maybe a few seconds, and you want to go, and you were actually circled by some security service. Not nice. So we believe for the future is a combination of technology that, as you mentioned yesterday, most importantly, one thing is behavior analysis. Another behavior analysis can be done by actually the cameras. So this is something very important because it does pick up the people which is suspicious, more suspicious. And then terahertz is another solution which helps to, because cameras, even it's thermal cameras, you can only see the surface. Terahertz will be able to say that if you have typical arms, for example, cold weapons, knives, or guns concealed under the clothes, and it can also tell you if it's only a cell phone. So it's just a screening, which is doesn't interfere in the freedom of the passengers. Then, in case by these two measures, you find someone is really suspicious, you can take measures by this way. So this is what we think in the moment will be a future for a few years. But we are also looking forward for even better technologies, more detectability, but less interrupting of the passengers.
Thank you. And what is your expectation about implementation of the new standard 3 screening for passenger luggage, that we don't need to take electronics and liquids outside of our bag? This is what we on the airport are requiring, because this will speed up the process, and this will eliminate also stress for people that are confiscating or taking the liquids on the special EDS or some other liquid detection system. So we know the standards, but we know when it will be practical to implement. Probably technology is already here, but it's too expensive for everyday use. So this is what the airport are looking for.
For this, I think it's a very good question. As we know that for the moment, there are many airports already started to testing this standard C3 machines, C3. Because especially for the efficiency of this machine, because many airports they are facing a problem about the throughput, especially when you have a summit time, the peak hours. Passengers will queue up in a long queue, and it's really affected the experience of passengers. So for the big airport, we don't think it's in the moment it's a trend to replace all the machines to this type of machine, also because of the cost. But for airports, having one or two of these machines, for middle-sized airports, to have one or two of these machines, 2 lanes, maybe it will be helping to relieve the pressure during the peak hours, because passengers don't need to take out the liquid and electronics. So as I know that many airports are now testing the technology, and a few airports are already starting to use this technology. We would say that in the future, many airports will have at least 1 or 2 of these lanes to helping relieve their passenger pressure on the throughput. This is what.
So we are talking about Horizon 2020, 2021, or further on?
Actually, we already got some projects this year in some specific airports. Mm-hmm. There are a few airports will be already starting to use this by next year, 2019. And we would say our expectation is that the more airports will be starting to use this technology around 2020 and later. But we see that many airports are very interested in the efficiency improvement of this technology.
Yeah. Thank you. Same future question for Mr. Bjorn. So when do we expect that we are going to fulfill passenger screening requirements from IATA screening point of the future, that we will just walk and you are going to screen without stopping us, putting hands down, up, taking the elements from the pocket? Is it too far to speak about this? We know the blueprint from these requirements for 2020, obviously it did not happen. So what you as a technology producer can promise us?
Well, number one, yes, we can promise, but I can't tell you anything. So by next year, by summer next year, you will hear more from Rohde & Schwarz in pertaining to walkthrough detection. To be honest, the way we see it at the moment, walkthrough is possible. We do have the technology, not based on terahertz, based on a different technology. But it will not be, and you mentioned this as well, it will not be as precise as millimeter. So it will be good for public events, for government buildings, partly for prisons, for visitors of prisons, for example, anywhere where you have a big influx of people. Of course, also before the terminal, entering a terminal, this will be good. But if you look at the technology that Rohde & Schwarz has produced in the last 10 years in this field, I always say we're at 64 milliseconds right now. Every year we get faster and faster, and the time will come where you'll be able to walk through. It will be precise enough. It will, from the security point of view, it will be enough to detect everything that needs to be detected at an airport. And I mentioned this also because in other sectors you're looking for totally different items. You can imagine in a prison you're looking for completely different things than you're looking at an airport. So we will have this in the future. Rohde & Schwarz has committed a lot of research money to this, and Rohde & Schwarz is a large company, which is a good thing. I like to work for them because I can see that they can fund these projects, and the priority of becoming the #1 body scanner technology and company in the world is very high priority for Rohde & Schwarz. On the other hand, again, the practical side, and you will notice as well, what's the use of us becoming extremely fast if the luggage is still waiting?
Yes.
So this is something where we're looking very closely also at companies doing luggage scanning. Rohde & Schwarz is not interested at the moment in doing any kind of luggage scanning. We're focusing on body scanning. But yeah, basically what we would achieve by becoming faster now, or even more easier, is that the queue would not be in front of our scanner, it would be after our scanner. But there would still be a queue.
So we are all looking for that as a customer of your new technology. Thank you very much for expressing your new products on the market. We are absolutely lucky to see that the progress is huge, and hopefully you are going to show us in the next conference also the up-to-date technology and some views of the future, screening point of the future, which will make our airport business easier and pleasure to be on the airport from the passenger point of view much higher. Please join me thanking these three distinguished guests who show us about their products for our customers.